Okay, so today we're going to go ahead and go over an AP Physics C Mechanics free response question from 2017. What I would encourage you to do is go ahead and go to the AP Physics C Mechanics website, print out this problem, try it yourself, and then you can check back in on the video to see how to do it and kind of grade yourself. I will also go over the scoring rubric and kind of give you a guide of like if you're getting approximately this many points, that's a 5, a 4, a 3, 2, 1, so on. So great, go ahead and pause this, try it, and then check back in. Okay, so let's go ahead and look at it. So look at this problem. Looks like a pulley system, Atwood machine. What I want you to do is, let's look at this. So we got to draw a free body diagram, block of mass M1 and M2. We love drawing free body diagrams. So we got, let's see, it's a rope attached to both of them. So there's going to be tension pulling upwards. I'm just going to call it T, and both of them have gravity acting on it as well. So we got FG going down. So FG, and this one is going to be M1G, and then this one is going to be FG equals M2G. Okay, one thing I realized, the relative lengths of the arrows should show the relative magnitudes of the forces. So let's see, which way is the system going? M2 is always greater than M1, so it's going this way. So if we look at the system on the right, if M2 is greater than M1, that means FG has got to be greater than T. So I'll make sure to draw FG a little bit bigger, a longer arrow than T. And then on the other side, I should make sure to draw FG shorter than tension. There we go, that's a little bit shorter. Perfect. Okay, so this one was out of 3 points. So to get all 3 points, you need to indicate both of the tensions are the same size. So that's going to be 1 point right there for indicating tension the same. And then you'll get 1 point for each of the free body diagrams below. So if you had for M2 that FG was bigger than tension, that's 1 point. And then for M1, tension needs to be bigger than FG, that's another point. So 3 points total. Okay, so for part B, it looks like we need to find the acceleration and prove that the acceleration is this statement right here. So I'm going to go ahead and look at my free body diagram. I'm going to go ahead and draw it on here too. So we got, oopsie, sorry about that. So we got FG going down, we got tension going up, and then we got FG going down. What I do for these problems is I always say that the direction it moves is the positive direction. So I'm going to say this is the positive direction. So I know FG right here is the positive, tension is negative, it's moving upwards, so this tension positive, and this FG negative. Perfect, let's go ahead and set up an F net equation for each block. So for block M1, we got F net equals tension minus FG. So now I can go ahead and plug everything in. So we got, this is going to be M1 times A equals tension minus M1G is our equation for M1. For M2, similar idea, F net equals, this time FG is the positive force, minus tension. So we got M2A equals FG, which is going to be M2G minus T. And I realized they use capital M's for these. I should make sure to be careful with my notation and do the same thing. Okay, so we got 2 equations, 2 unknowns. We want to solve for acceleration. What I like to do is I like to solve system of equations, and I like to add these 2 equations together. Let's go ahead and add them together and then do some simplifying. Equals what? M2G minus T. We'll go ahead and add those together. So on the left, we got M1A plus M2A equals M2G minus M1G. So positive T and negative T cancel out. Okay, now it looks like we just need to do some factoring. So I'm going to say it's going to be A times M1 plus M2 equals, okay, they factor out the G as well. So it's going to be M2 minus M1 times G. And then we just got to divide by M1 plus M2. So then we got M2 minus M1 over M1 plus M2 times G. And there we go. We proved it. Okay, so our points for this is we're also out of 3 points. You get 1 point for correctly setting up F net for block M1, and 1 point for correctly setting up F net for block 2. And then you get 1 point for combining the 2 equations and then correctly solving for acceleration. So there's your 3 points. Okay, So C is when it starts to get tricky. So we want to indicate which quantity should be graphed to yield a straight line whose slope could be used to calculate a numerical value for the acceleration due to gravity g. Anytime you see something like that, you know that you're going to be linearizing. You have some equation right here. So we have this equation. We're going to need to linearize that to make it a linear set of data. So let's go ahead and look at it. So this is our equation. So it's m2 minus m1 over m1 plus m2 times g. Okay, so we're trying to solve for g somehow. So what I'm going to do is our linear equation is y equals mx plus b. So in this case, kind of comparing the equations, it looks like the y variable is like a, and then it looks like our other variable, so the m2 and m1, we're changing those things, that is going to be our other variable essentially. So x is going to be this whole thing right here. And then whatever we have left over, g, is going to be our slope. So our slope is actually just going to be g. And then it looks like there's no b, so this is essentially like plus 0. So our b or y intercept in this case is just going to be 0. So on our vertical axis, we are going to have a, and on our horizontal axis, we are going to have m2 minus m1 over m1 plus m2. Okay, it looks like for this, it is just worth 1 point, and you just get 1 point for correctly saying vertical axis A, and then this other stuff on the horizontal axis. Just keep in mind that for this one, if you had like a different variety, it could also be correct as well. Or if you switch the horizontal and vertical, that would also work as well. Okay, so we also, with this one, sorry that I didn't do it right away, we need to make sure to use the remaining rows to record any quantities indicated. So we're going to need to find m2 minus m1 over m1 plus m2. I'm just going to go ahead and do it in one box right there. So if we look at the first one, it's just going to be 2 minus 1 over 2 plus 1, 2 plus 1. So that's just going to be 1 over 3, or we could say 0.33 repeating. Go ahead and do that for each of those, and you can check your work on that. Okay, so you can go ahead and check your values for those other quantities as well. Let's go on to the next part. Okay, so now we want to go ahead and plot the data for the quantities from C. So clearly scale and label axis and kilo units if appropriate. Great. So let's go ahead and do that. So we know on the vertical axis we wanted A, which acceleration is going to be meters per second squared. And then on the horizontal axis we wanted m2 minus m1 over m2 plus m1. So the units for this one, it's like mass over mass, so kilograms over kilograms. That'll just cancel out. So this scale is unitless. Okay, so let's go ahead and look over our data and choose a scale. So for acceleration, oh, that's pretty easy. It goes from like 1-ish to a little over 4, and I got 5 things. I'm going to go ahead and count by ones for acceleration. And then for the other scale, it looks like we go to a little less than 0.5. I'm going to count by 0.1 on the other scale. So let's see. So let's go ahead and graph it. So we got 0, 0. This is going to be 1, 2, 3, 4, 5, and then this is going to be 0.1, 0.2, 0.3, 0.4, and 0.5. Okay, so now go ahead and graph it, and then you can check back in on the video. Okay, so here's all the data plotted, so you can go ahead and check that. But for the last part, we want to draw a straight line that best represents the data. Always make sure you use a piece of paper or like a ruler to make sure that line is straight. So I'm going to go ahead, and again, about the same number of points above and below your best fit line. Perfect, so around like that. Okay, so this is out of 3 points right here. So you get 1 point for using a correct scale on the X and Y axis and making sure that scale fills up over half of the graph. So that's 1 point right there. Another point for correctly plotting the data. And then a third point for drawing a best fit line. So I'll go ahead and write that down. Okay, so we went ahead and I went ahead and wrote down what the points were for that one. Okay, so let's go ahead and go to the last part. So for E, using your straight line, determine an experimental value for G. Okay, keep in mind, anytime it says using your straight line, you are going to have to find the slope of that line. So let's go ahead and do that. So this is, I'm going to go ahead and write E to the side. So slope we know is rise over run. Make sure when you do the slope, you're always choosing points on your best fit line. So I'm going to do this point right here. And then I'm also going to do, oh, this looks like a nice little point right here. Okay, so this one looks like, so we go over and up. Okay, so our rise, it looks like we go up by 0.2 for each block. So 0.2, 0.4, 0.6, 0.8, 1. So our rise is 1. And the units of that are meters per second squared. Our run looks like we go over one whole box is 0.1. No units for that. So that's just going to simplify to 10 meters per second squared. Okay, so if we go back to our linearizing, again, we know y equals mx plus b. So we know acceleration was m2 minus m1 over m2 plus m1 times g. And again, the y variable, if we match this up, is a. The x variable is this whole thing right here. So whatever we're left over with is just the slope in this case. So in this case, the slope is g, which we found the slope to just be 10 meters per second squared. And you know what? Is that what it should be? Yeah. The acceleration due to gravity should be on the surface of Earth, should be around 10 meters per second squared. So that makes sense. Okay, so this part is just worth 2 points. You get 1 point for correctly calculating slope, and then 1 point relating the slope to g. Okay, so let's go ahead and look at this last part. So this is now our new experiment. So let's go ahead. I always like to draw a free body diagram for it. So for M1, we got Fn, we got tension, we got Fg. For M2, we got tension and unit. Okay, so we have to compare the tension between this experiment and the previous one. Well, if we look at this, the system is going to accelerate way at a much greater rate because it's like there's nothing really holding back M1 over here. It's just gravity right here, acting on M2, pulling on M1, M2. M1 doesn't have the force of gravity in the direction of the Earth, pulling it back. So acceleration is going to increase. So if acceleration increases, then we know the difference between these two forces, Fg and tension, has to increase. So if acceleration increases, then Fg needs to be much bigger than little tension over here. So then the tension is going to be lower in this experiment, just because the system is accelerating at a much greater rate. For this one, you get 1 point for, so this is worth 2 points, 1 point for lower, and then 1 point for correct explanation. Okay, so let's go ahead and look at the last little part right here, part G. The value determined for the acceleration due to gravity is lower than in the first experiment. One physical account that could factor for this lower value and explain how this factor affected the experiment. Okay, so realistically, now this, okay, it says M1 is on a smooth horizontal table, but realistically, there is going to be a little bit of friction involved. So if there's some friction, that will make acceleration decrease. So if acceleration will decrease, then if you go to your acceleration versus like M2 minus M1 over M2 plus M1, which now that'll be different because we just have M2 hanging, so it would essentially be that. But that'll make the slope of the line decrease, which if that makes the slope of the line decrease, then that will make G decrease as well. And this is actually just worth 1 point right here. So let's go ahead and you can add up all the points that you got right now. Okay, so kind of my general rule of thumb is for AP score rubric, and this is just kind of like my recommendation. It'll be, AP will probably be similar, maybe a little bit different, but if you're getting between 9 to 15 points on every response, that is going to be an AP score of a 5. If you get between 7 to 8, that's an AP score of a 4. If you're getting around 6 points, that's an AP score of a 3. 4 to 5 points is an AP score of a 2, and 0 to 3 points is an AP score of a 1.